Over 10,000 satellites have been launched worldwide. Many of them are in low orbit, no more than 600 kilometers above Earth. Two problems arising are orbital congestion and orbital debris. An accident in orbit would come as no surprise. How do we make space safe? A satellite can be lost when a geomagnetic storm induces atmospheric re-entry. During a 2022 mission, SpaceX lost 40 of 49 communication satellites to a geomagnetic storm. These were low-orbit satellites, and Earth's atmosphere caused the problem. Why do the atmosphere and geomagnetic storms knock out satellites? Geomagnetic storms heat up and expand the atmosphere. This makes the atmosphere denser along satellite orbits. The resulting increase in atmospheric drag causes satellites to slow down and re-enter the atmosphere. One solution to the problem is a real-time simulated forecast of global atmospheric density. Others are the two upper atmospheric density forecasts, one for brief geomagnetic storms, and the other for the longer 11-year solar cycle. This space weather forecast is a useful resource. The aim is to help streamline and extend satellite operations and make space safer to use, as well as to achieve the SDGs in space and usher in an era of sustainable space. NICT. Autonomous driving, remote driving, and remote management need GPS positioning. It is a must for safety and reliability. The satellite positioning must be highly precise, down to the centimeter. In September 2017, the Geospatial Information Authority of Japan reported that GPS positions were 10 meters off. What was the cause? More total electrons in the upper atmosphere. When there are more electrons, radio waves and GPS signals experience latency and less accurate position estimates. 10 meters is a big problem. NICT's Space Weather Forecast provides real-time maps of electrons and disturbances. These resources are useful for more accurate and reliable GPS services. NICT delivers safety and reliability with precise satellite positioning. NICT. "2021 marked the dawn of civilian space travel. There are now Aurora tours both on Earth and in space. Rapid space transport is also on the rise. And in around 2030, the civilian space station operations will begin. If you take an Aurora tour, you want to know when the lights will appear, right? Solar flares create auroras. When a solar flare causes a geomagnetic storm on Earth, it rains charged particles from space onto the atmosphere around the poles. The reaction in the atmosphere produces lights we call auroras. Auroras are predictable. NICT already releases an Aurora forecast map and makes the data available. A flight from Japan to the US exposes passengers to radiation equivalent to an X-ray scan. Even aboard an aircraft, we are exposed to solar radiation. A solar flare can momentarily increase that exposure by 100 to 1,000 times. The effect is multiplied in the thinner atmosphere at high altitudes. And if traveling in space? The space weather forecast includes publicly available world dose rate maps. They're available for aircraft 12 kilometers up, balloons 30 kilometers up, and spacecraft 94 kilometers up. The International Civil Aviation Organization, or ICAO, is already using them. Space will become part of everyday life. We will offer new services to keep contributing to a future society that extends into space. NICT.